Hi, welcome to lesson 5.2, Congruent Polygons. So we are on page 128. Now for page 128, you are going to need a half sheet of paper and you're going to glue that on 128. On page 129, you are going to cross off these two. And at the bottom of page 129, you are going to do example number 1 here and example number 2 right there. On page 130, you are going to do problems 4, 3, and 5 on page 130. 4, 3, and 5. So pause the video and write it down so that you don't forget. All right, let's go ahead and go to our exploration, which is on page 128. Now, it's not so much of an exploration. It's more like an introductory to congruency. Now, we're going to start with an example. The example is a triangle. So if you have, for example, triangle A, B, and C congruent to triangle D, E, F, there are a couple of corresponding parts that are going to be congruent and a couple of corresponding sides that are going to be congruent. Now, if it helps you, go ahead and draw the following triangles. So I'm going to draw triangle A, B, C. And I'm going to draw one triangle that is as much as exactly as the same as that one as possible. So D, E, and F. Now, based on this, these two triangles are going to be congruent, which means that they have two things in common: their angles and their sides. Okay, so we're going to focus on the angles first, and then their sides. So let's look at the angles. Because these two triangles are congruent, angle A corresponds to angle D. That means that angle A and angle D are going to be congruent. So angle A congruent to angle D. Angle B is going to be congruent to angle E. So B congruent to E. Angle B congruent to angle E. Please note the notation. There's a difference between equality and congruence. And then third, angle C corresponds to F. So angle C is going to be congruent to angle F. So these are the three corresponding angles when you have a triangle congruent to another triangle. By the way, this is called a congruence statement. Make sure you know that, because they're going to ask you to write one. Okay, so this is a congruence statement right here. It tells you exactly what's congruent to what. Now, looking at the diagram again, okay, let's talk about the sides now. So you have side AB. Side AB is going to be congruent to side DE. So AB congruent to DE. So AB congruent to DE. Yes, order does matter. Okay. A lot of people like to write it as AB congruent to ED. No, you have to follow the same order that you have here. You have AB, DE. The next one is BC and EF. So BC and EF. Notice I'm doing two hash marks instead. If I were to do one, then I would be saying that this one and this one are the same, and that's not true. So BC congruent to EF. And the last one, AC and DF. So I'm going to use 3. AC congruent to DF. Okay, and we call these corresponding parts. So this is true when you have two polygons that are congruent. So if you have a quadrilateral, a pentagon, or a hexagon, and they happen to be congruent, you basically follow the same procedure. Okay, so if they tell you these two are congruent, what are their corresponding parts? Simply list the angles and list the sides. Okay, let's move on to page 130. Now let's talk a little bit about triangle congruency. Now, triangle congruency is both reflexive, symmetric, and transitive. So what does that mean? It means that a triangle is congruent to itself. I mean, it makes sense. A triangle is congruent to itself. Okay, they have the same size, they have the same angle measurements. Okay, so that's a reflexive property. The next one is the symmetric property. If you have triangle ABC congruent to triangle DEF, okay, then triangle DEF is going to be congruent to triangle ABC. That's called a symmetric property of triangle congruence. And now you have the transitive property that states that if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then triangle ABC is going to be congruent to triangle JKL. Transitive property of triangle congruence. And this is going to be very, very useful in the future. So yes, we do need to memorize these as best as we can. Don't worry about memorizing the letters because sometimes in a diagram, the letters are going to be different. Memorize the concept. Now, in this theorem right here, we have what we call the third angle theorem. Now, let me tell you something. You will need this theorem multiple amount of times throughout the rest of the book, especially chapter 5. It says, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also going to be congruent. And look, it makes sense. If these two are congruent and these two are congruent, and they both have the same angle sum because all triangles have the sum of 180 degrees, if you were to subtract these two from 180 and subtract these two from 180, those measurements would be the same. That would mean that C and F are going to be congruent. So if you have two triangles that have two pairs of angles that are congruent, then you can assume that the third pair is also going to be congruent. That's going to come very, very useful in the future as well. So let's go ahead and start our examples. Here is our first example. Try to zoom in a little bit. Okay. So it says, write a congruent statement for the triangles and then identify all pairs of congruent corresponding parts. So there are literally different ways that you can do this. Okay? There is no general rule that you have to start with any specific letter. But traditionally, you like to start off and go alphabetical. So J, K, and L. At least your first one has to be. Okay? So triangle JKL is going to be congruent to. Now, if you do not start with JKL and you start with KLJ or LJK, it's fine as long as you have the right order of the letters in the second part. So as you can see, J here is congruent to T. So J is congruent to T. That means T goes first. K here is congruent to S. And L is congruent to R. Now, a lot of people like to start with the number of arcs. So you see how this one has 1, 2, and 3? So triangle LJK congruent to RTS. You can do that too. Like I said, there is more than one way of doing this. Okay, there are literally like almost 6 different ways of doing this. This is one of the ways. So we're done with that. Now we're going to identify all pairs of congruent corresponding parts. So let's begin with the angles. Now, it's very easy to figure it out because you can use the congruent statement or you can even use the same diagram. Okay, I'm going to show you how to do it using the congruent statement. J and T are congruent. Angle J congruent to angle T. K to S. And L to R. There you go. There's all your angles. Now you have to list your corresponding sides. So if you use the diagrams, you run the risk of writing the letters out of order. Because for example, you'll say JK and ST, okay? Or JK or TS. So you run the risk of doing the letters in the wrong order. So I like to use this instead. So the first one would be JK. So JK is going to be congruent to JKTS. KL congruent to SR. And now here's you got a choice. Some people like to do LJ. I like to always go left to right, so I like to do JL. Not that there's anything wrong doing it the other way. It's just mainly what I like. So JL and TR. So these are the corresponding sides and angles of these two triangles. So that's example number 1. Let's look at number 2. Okay, in example number 2, here's where you guys have to be really careful because a lot of people like to look at a problem like this and simply go left to right. Like they think, oh, 102 must be this one must be this one, this one must be this one, and this one must be that one. Please remember to always look at your congruence statement. Okay, so let's take a look at which one we want to solve first. It says find the value of x. So let's look at A first. So x here is in two different locations. It's in here and it's in here. So I'm going to look at this part right here. So here you have QR. Well, what segment is QR congruent to according to our congruent statement? Okay, QR is congruent to FG. Okay, so if you thought of equaling 2x minus 4 to the 8, you would have made a mistake. Always go by this. So here, QR is congruent to FG, which is this one. Now you can go ahead and make your substitutions easily because QR is 2x minus 4 and FG is 12. And you can just simply solve. So you add 4 to both sides and you get 2x equal to 16 divided by 2 and x equals 8. And we're going to need that answer for part B. Now for part B, they want me to solve for y. Y happens to be here and it corresponds to angle Q. Angle Q is congruent to what angle? Now if you think it's going to be congruent to D, you are wrong because Q happens to be the third one here and the third one here happens to be F. So it's congruent to F. So angle Q is 6y plus x, and angle F happens to be 68. Now we already know what x equals because we just solved for that. So 6y plus 8 equals 68. You subtract 8 from both ends and you get 6y equals 60. Then divided by 6 and y is equal to 10. Oops, go up a little bit. So y is equal to 10. And therefore you have now solved for both x and y. But here's the main thing that I want to emphasize, and it usually takes students a bit of time to realize that because they just want to jump to the problem and solve for something. But when they realize they didn't equal the right parts, they did all that work for nothing. So why? Because they did not pay attention to this. Pay attention to this. Okay. Kind of like how your parents tell you, don't do this, don't do this, don't do this. And then what do? You do that. And then you get in trouble. All right. So people always get confused because they always want to know, well, am I being asked to do a proof, or am I being asked to simplify something? What am I being asked to do? Look, if it doesn't say proof, then it's not a proof. Okay. So here's a good example of one. It says you divide the wall into orange and blue sections along JK. Why would anybody want to do orange and blue? I don't know. Will the sections of the wall be the same size and shape? So you have this wall. Obviously, the walls all have, their right angles. They're all going to be parallel. Okay. So what they want to know is this and this going to be congruent? Okay. So let's look at it. Let's look at the first shape here. Okay. So I'm going to do the one on the left hand side. Okay, which is A, J, 1. Got the right angle there. 1, 2, 3. Got the right angle there. Got 2, and you have 3. Now this is everything that they're giving you here. Okay. Now if I were to draw this one, now if they don't look the same, don't worry about it. It's all about what's in there. Okay, and you have B, you have J, K, and C. So remember, in order for us to say that these are congruent, they have to have the same sides, the same angles matching. Okay, so let's start with the number of sides. Okay, so let's start with the sides. You have side AD and BC congruent. So we're good. You have AJ and KC congruent. So we're good. You have this one and this one, JB and DK, also congruent. So that's good. You have 3 pairs. You need a 4th one. So here's where we are going to look at one of the most useful tools in geometry. Now, isn't JK the same size on both of these? Isn't this one and this one the same one? So therefore, it should be that they are congruent. So that means, yes, they are congruent. So let's look in terms of the sides first. Okay. So if we look at this, you have AD congruent to CB. Okay. Now that's given, believe it or not. You have AJ, okay, congruent to CK, that's also given, and you have DK congruent to BJ. Okay, so you have 3 things that are congruent and it's given to you. Now let's look at the angles. Okay, so for the angles, you only have 2 pairs of angles. You have B with D and C with A. So B, angle B, congruent to angle D, and angle C congruent to angle A. So here's the thing. I need 2 more angles to be congruent and 1 more side to be congruent, and then boom, these 2 will be considered congruent. So what we just said was JK. JK is congruent to itself. Okay, so I'm going to use 4. Okay, so JK is going to be congruent to KJ. Okay, why? Because of the reflexive property of congruence of segments. Okay, so this is my new thing. This is what we derived. Now, as far as the angles go, keep in mind one thing. Okay, because these 2 lines right here are perpendicular to the same line, there's a theorem back from chapter 3 that would state that these lines are going to be parallel. So that means that AB and CD are parallel. So what does that mean? That means that JK acts as the transversal. So that makes 2 and 3 alternate interior. So angle 2 congruent to angle 3 by alternate interior angles theorem. Okay? So for the same reason, okay, these two lines are perpendicular to the same line, making these two lines also parallel. So for the same reason, 1 and 4 are also going to be alternate interior. Not 2, sorry. 1 and 3. Hold on, I'm tripping here. 2 and 3, 1 and 4, my bad. 1 congruent to 4. Also by alternate interior angle theorem. So now you have 4 sets of pieces of information that proves that this shape and this shape are going to be congruent. Now this is technically not a proof, it's more like a plan. But if I want to do a proof, I would use all this information to do that. All right, that was example number 3. Let's look at the next example. Okay, for the next example, example 4, it says find the measure of angle BDC. So BDC. In order to do that, I need to figure out what this whole angle here is. But I want you to take a look at something. This angle here is 30 degrees. This one here is marked also as 30 degrees. So this angle right here is also going to be 30 degrees. And this one right here is going to be 45 degrees. Okay? So my goal is to figure out how much this is going to be, how much this angle is going to be. So I want you to look at one thing. Angle BDC is congruent to angle ACD. So BDC, ACD, they're the same thing. Now if I just focus on this triangle, triangle ACD, I would have a triangle that looks something like this. A, C, D. I know this one here is 30. I know this one here is 45. So in order to get angle C, I would have to, or angle ACD, I would have to do 180, take away the sum of 30 plus 45, because the sum of the angles is 180. So that would be 180 minus 75, which is going to be 105. So this angle right here is 105. Therefore, the measure of BDC is going to be 105. Why? Because they're congruent. Okay, so that is example number 4. If you want to pause it and go back and see how I did it again, go for it. Let's look at the last one. Now, it says use the information in the figure to prove that the triangles ACD is congruent to triangle CAB. So yes, we are doing a proof. So remember, in order to show that these are congruent, as of right now, we only need to show that all sides are congruent, all the corresponding sides are congruent, all the corresponding angles are congruent. So let's look at what we have first. Okay, so what do we have according to the diagram? According to the diagram, we have a couple of sides that are congruent. Okay, so let's list that. Okay, you have AD. Okay, AD congruent to CB. AD, CB. That's given. Okay, the other side is CD. CD congruent to AB. Now, all of these right here, they're all givens. They're all in the diagram. So remember, in order to prove that the triangles are congruent, I need 3 pairs of angles and 3 pairs of sides. So 3 pairs of sides is going to be easy because look, AC is congruent to itself. So AC is congruent to CA. Now, why did I switch the letters? Look, AC, CA. And what's the reason for that one? The reflexive property of congruence. of segments, or just reflexive property of congruence should be fine. So look, this is what we came up with. Maybe purple's a little too dark. Should probably switch to yellow. All right, fourth, let's look at the angles. Okay, now you have this one and this one. I'm going to have to use 3 different letters. So you have angle DAC congruent to angle, look, DAC BCA. That's given. You have this one with the 2 arcs, ACD. Okay, ACD, angle CAB. That is also given to you. It's in the diagram. So you need a third pair of angles. So keep in mind, one of the theorems that we did learn was that if you have 2 triangles that have 2 pairs of angles that are congruent, then the third pair is going to be congruent as well, which in this case it's going to be angle D congruent to angle B. And what's the reason? Look it up. Third angle theorem. Okay. So now that I have my 3 pairs of sides and my 3 pairs of angles, okay, now I can state that these 2 triangles are going to be congruent. Okay, triangle ACD congruent to triangle CAB. Okay, what's the reason? I don't know, I guess definition of congruent triangles. Now, that's a lot of work. Keep in mind, guys, our goal for this chapter is to do the same thing, prove that triangles are congruent with less information. And for that, we're going to be developing tools in the next coming lessons. So pay very close attention. All right, please make sure you guys are working on your extra practices, and I will see you all later. Have fun.